Good afternoon, everyone. Caresoft Technology would like to welcome you to our Cloudflare webinar, Onboarding DNS with Cloudflare. Before we get started, I would like to go over a few housekeeping items. The audio portion of this webinar can be heard through your computer speakers. All audio lines have been muted to reduce any background noise. If you have any questions throughout the presentation, please use the chat pod at the bottom of your screen and we will do our best to answer all of your questions at the end of the presentation. If for some reason we do not get to your questions, our team will certainly follow up with you offline. Just to tell you a little bit about Caresoft, we are a trusted government IT solutions provider delivering software and support solutions to federal, state, and local government agencies. Caresoft maintains dedicated teams to support sales and marketing for all its vendors, including Okta, CrowdStrike, and Splunk. Our contact information will be at the end of the presentation, so please do not hesitate to call or email us for any of your needs. This webinar is being recorded and a copy of the presentation will be emailed to you. At this time, I would like to introduce our speakers for today. Derek Gilmore, Field Solutions Engineer at Cloudflare, and our moderator, Tim Schneider, Senior Strategic Solutions Engineer at Cloudflare. Derek, I'll pass it on to you. The floor is all yours.
Thank you so much, Anna. As mentioned, today's conversation is really going to revolve around DNS and really how we onboard customers to Cloudflare's DNS solutions. So I really want to start with, before we dive into the kind of the Cloudflare side of things, just briefly cover like why DNS as a service is really so important and why organizations choose solutions like Cloudflare for managed DNS. So, as everybody here probably knows, like DNS is really one of those absolutely essential services that kind of underpins how the internet actually functions. It's the thing that prevents us all from having to know like the actual IP address of google.com or any of the other, common sites that we visit on a daily basis. And really, without it, all of the time and effort and money that gets invested into building really highly resilient, secure web services, it's kind of for nothing because nobody's able to actually get to the services in the first place. And so more and more organizations are beginning to understand that their DNS implementation really does represent kind of an extremely vulnerable attack surface in their security strategy. And this is certainly not an exhaustive list of all of the things that you have to consider when you're talking about handling DNS internally or with a managed provider, but it's some of the really big ones. And so things like DNS cache poisoning, also known as kind of DNS spoofing, this is kind of where an attacker will essentially enter false information into a DNS cache so that DNS queries return an incorrect response, and then users are directed to the wrong websites and often, compromised websites. Um, Attackers are able to kind of poison DNS caches by impersonating DNS servers and then making requests to DNS resolvers and then forging the reply when the DNS resolver queries a name server. And all of this kind of is possible because DNS servers rely on UDP. DNS is on UDP 53 as opposed to TCP. And with UDP, there's never any guarantee that the connection is open or that a recipient is ready to receive the connection. And as a result, attackers are able to send a message via UDP and pretend it's a response from a legitimate server, and basically by just forging the header information. And because there's no good way for DNS resolvers to verify the data in their caches, incorrect DNS information can ultimately remain in the cache until the time to live expires, or they're removed manually by administrators. Another really, really common vulnerability of DNS is distributed denial of service attacks. In Q4 alone, 16% of all DDoS attacks were DNS flood attacks. And the overarching goal of this is to basically overwhelm the DNS infrastructure with just a massive amount of queries that it has to resolve, and thereby causing resource exhaustion on the servers themselves, or potentially overwhelming the firewalls that sit in front of the DNS infrastructure. Regardless, the result is effectively the same. And once DNS becomes unresponsive, pretty much everything relying on domain resolution also becomes kind of unavailable. And then the last really kind of big threat I want to talk through is the idea of DNS-based amplification attacks. And this is essentially a reflection-based volumetric DDoS attack where an attacker is going to leverage the functionality of open DNS resolvers. So, for example, Cloudflare's 1.1.1.1 public resolver, for example, in order to overwhelm target servers or networks with an kind of an amplified amount of traffic, which again renders the DNS server and its surrounding infrastructure kind of unaccessible. And pretty much all amplification attacks exploit the disparity in bandwidth consumption between an attacker and the targeted resource. And when that disparity in cost is magnified across a lot of requests, the resulting volume of traffic can really cause disruption in network infrastructure. And so DNS is particularly susceptible to this because by sending small queries that get a large number of responses, an attacker is able to kind of do more with less. And by multiplying this across, like a botnet, for example, making similar requests, the attacker can not just obfuscate their detection, but also gets the benefit of a greatly increased amount of attack traffic. So, how does Cloudflare handle DNS? So, our authoritative DNS offering is really broken into kind of two configurations. Primary DNS, which is where a customer wants to move all DNS functionality to Cloudflare. So, if the IP address of a site or load balancer changes, that change would be made directly within the Cloudflare dash or through our API. Secondary DNS is where the customer wishes to kind of maintain their existing DNS infrastructure. And rather than migrating the zone, they set up transfer between the existing DNS servers and Cloudflare. And whenever an update is made to the zone, the existing DNS environment notifies and then updates Cloudflare. And in this setup, customers are able to protect their existing DNS infrastructure by allowing it to only talk to Cloudflare and not have to answer broad DNS requests coming from the internet. And this does also help kind of remove some of those common security issues that I was talking about related to hosting DNS yourself. So why choose Cloudflare over kind of any of the other managed DNS providers out there? There's a lot of them. For starters, we are the fastest authoritative DNS resolver available, and we have a 15 millisecond average lookup latency globally and a 6 millisecond average lookup within North America. Our authoritative resolvers see around 44 million DNS requests every second, and that puts us at around 3.8 trillion requests per day. In addition, when a customer makes a change to a DNS record, those changes are reflected globally in under 5 seconds. So those days of waiting for DNS changes to propagate across your DNS infrastructure, that's kind of those are gone. The thing that powers our DNS services and really every other service that Cloudflare provides is our global Anycast network. Um, every single Cloudflare service runs at every single location. And so that means that every single one of the blue dots you see here is acting as a DNS resolver for our customers' zones, with requests being answered by the closest Cloudflare point of presence to where that request actually originated. And so as a result, you end up with a DNS solution that is both performant and very resilient. Just real briefly, I kind of want to touch on some of the features of our authoritative DNS offering. So I'm not going to go over kind of everything here, but there are a few that I do think are worth highlighting. In that previous map that I just showed, all of those Cloudflare points of presence both respond to DNS queries as well as hold copies of the zone. And so this means that we don't have to rely on any specific points of presence for DNS services. It also means that when a customer makes a change to DNS records, they are propagated globally extremely fast so that essentially you don't have to wait to see the effect of the changes occur on the internet. Push button DNS sec is another extremely useful kind of security feature that Cloudflare builds into its DNS offering. And DNSSEC is part of the solution to those DNS spoofing attacks that I kind of mentioned at the top of the conversation. DNSSEC creates a secure domain name system by adding cryptographic signatures to existing DNS records. And these digital signatures are stored in DNS name servers along with the common record types like what everybody expects to see, A, quad A, MX, CNAME records. And by checking its associated signature, you can verify that a requested DNS record comes from its authoritative name server and kind of wasn't altered, in route as opposed to like a fake record injected in a man-in-the-middle attack. Another feature that customers constantly say is helpful is the ability to do CNAME records at the apex. So many DNS providers require that at the root of a domain. So, for example, Cloudflare.com, it has to be pointed at an A records, meaning it has to be pointed at an IP address. So with Cloudflare, you can actually point the root of your domain at a DNS name. So that allows you to do things like use like DNS-based load balancing. Uh, the ability to support reverse lookup zones is also very helpful, especially with customers that own their own IP blocks, because this means that they can really fully replace their legacy solutions with Cloudflare managed DNS, and things like email gateways and forwarding still all works properly because you can host the reverse lookup zone on Cloudflare also. The last thing that I'll kind of talk through here is um, when someone moves over to our authoritative DNS platform, they're also protected from those common DNS DDoS attacks. So customers' DNS is effectively protected by the exact same DDoS mitigation system that Cloudflare employs to protect its own network. And how we see this play out is the most common type of DNS DDoS attack we see is what's referred to as an NX domain or random prefix attack. And this is really where an attacker will send just a huge number of legitimately formed DNS requests to a set of DNS resolvers um, for host names that don't actually exist in the zone. But since the queries themselves are correctly formed, the DNS resolvers have to spend time and resources actually answering that request and saying, hey, I don't have anything by that name in this zone, which can eventually lead to the DNS servers failing due to a combination of resource constraints. And with Cloudflare, because we distribute the load of all of the DNS requests that we answer, and because we respond to so many DNS requests every single second, even these massive NX domain attacks end up just looking as like a rounding error to the total number of DNS requests we answer regularly. So because DNS is such a critical component to our customers, Cloudflare does try to offer a few different combinations for configuration options. And really what we're trying to do is meet the customer where they are in their DNS strategy. So the two most common configurations I see when kind of onboarding customers is really these two that are kind of shown here. Um, and with primary, this is effectively where the the zone file is actually held by Cloudflare. So we are responsible for the actual maintenance of the zone file. Kind of as I alluded to earlier, it means that we are the only DNS components kind of in the DNS configuration or in the DNS deployment, and we are also responsible for answering all external DNS queries that come in for the zone. In this hidden primary, or in a couple of earlier screens, I kind of referred to it as secondary. It has a kind of bunch of different names, hidden primary or secondary hidden master. Both names kind of represent the same thing, and this is really a configuration where a customer wants to keep their existing DNS infrastructure in the picture. They're not trying to get rid of it, but once again, Cloudflare, resolvers will actually be responsible for answering external DNS requests, and updates to the zone are made on the existing DNS infrastructure, and then those changes are reflected in Cloudflare. So let's talk through kind of what that actual deployment looks like. So for primary only DNS deployments, we have tried to make the process kind of as simple and painless as we can. It's one of the most common onboarding mechanisms that I see customers adopt, and there's some reasons for that I'll kind of cover. One of the main benefits to this is that when we're doing the migration to Cloudflare, this allows us to kind of pre-stage all of the DNS records ahead of time before we actually are doing anything. And that way, when it comes time for go live, we're not worried about doing configuration tasks along with kind of doing the migration. Uh, Cloudflare also tries to make this easy by supporting the ability to import bind files. For everybody that kind of doesn't know what those are, essentially what a bind file contains is really all of the records and their values for a DNS zone. So all the A records, MX records, quad A, all those kinds of things. And most enterprise DNS providers allow for the export of bind files. However, there are some managed DNS services that don't. Things like AWS's Route 53 or Azure DNS, you can't just inherently get a bind file out of them very easily. There's some creative options that you can have, but sometimes, based on the existing DNS provider a customer is migrating from, we might have to even manually create the zone on the Cloudflare side new if there's no way to actually get that data from the existing resolvers. As part of when you create a zone on Cloudflare, uh, what happens is you're assigned a pair of Cloudflare primary name servers, kind of what's shown here. And when it comes time to migrate DNS, really, there's only a few things that you need to consider. The first is that if the zone is already using DNSSEC, like what we were talking about earlier, that needs to be disabled on the old provider up to 24 hours prior to go live. And we just need to do that to avoid conflict between DNSSEC, really. And the other part of it is when we update the name servers at the domain registrar, once we really make that change, we kind of become at the mercy of global DNS propagation for when that change is actually reflected across all the major, public recursive resolvers. So things like, again, our Quad 1 or Google DNS or Quad 9. Yeah, the reason that I bring this up is because when we're transitioning from something like a hosted info blocks or bind servers, it's really important that until we see everything converge on Cloudflare's name servers, that we continue to answer DNS requests from that existing DNS infrastructure. I've seen customers kind of immediately shut down or cut off firewall access or deprovision DNS components after migrating to Cloudflare. And this can absolutely result in kind of lookup failures. And I often recommend to my customers when I'm working with them personally to use Dig Web Interface because it gives you the ability to run a compare for the NS records on all of the major public resolvers, and you can determine if DNS convergence has occurred. And then kind of once we see propagation complete, we can actually go back into the Cloudflare dashboard and enable DNSSEC with just the push of a button. Cloudflare will handle kind of creating the necessary DNS records, and we will also provide the DS records that are required to be added at the registrar. Let's talk through the other kind of major way that I see people kind of roll out Cloudflare DNS. So with secondary DNS, there is a little bit more work involved than the deployment versus primary. The reason that customers choose this deployment model over, say, a primary is that this gives them the luxury of keeping their existing DNS procedures exactly the same. So from a process perspective, they don't have to modify the way that they're used to maintaining DNS. They're still making the changes on their DNS infrastructure, and anything else associated with that can kind of remain in place. And I often see this method chosen by customers that have really large, full-blown DNS teams that have invested a lot of time and thought into their DNS architecture. And so, like, for example, if we've got a customer that has just a really large info blocks or Blue Cat deployment and they're not looking to remove those appliances from the environment, Cloudflare secondary DNS can provide them with kind of the same levels of performance and protection that primary offers, and they still keep, their existing infrastructure. So the way that this kind of differs in setup is that when you go to set up a secondary DNS zone, there's things that you have to get from your existing DNS provider. Mainly the three things I'm about to cover. So the first is you need to be able to have the external IP addresses that Cloudflare will send the zone transfer requests to. So we have to be able to talk to those existing DNS servers. The zone transfer type that you're planning on using to update Cloudflare is also required. And this is going to either be an AXFR, which is full, so the full zone, or IXFR, which is an incremental transfer. And then the last thing you need is a transaction signature information, or commonly referred to as TSIG. And this actually consists of a TSIG name, a secret, and an algorithm. And TSIG is effectively used to authenticate communication between a primary and secondary DNS server. This step is technically optional. You don't have to do it to initiate zone transfers, but for those customers that are security focused, which most people in this day and age are, this is something that we do support. So next, you essentially within Cloudflare, we would create a peer server group, those servers that we can talk to, those on-prem DNS servers that we can talk to, where we take that information that I just kind of covered and build out a peer DNS server group using that IP port, zone transfer, and TSIG. And then also within Cloudflare, we would build what is called a secondary zone. And we would just link that peer server group to the zone that we just created and choose a zone refresh timing, which effectively is how often is Cloudflare going to request zone transfers from the existing DNS infrastructure. Another consideration is, once we've completed all of those pieces of it, we can initiate that first zone transfer, and kind of all of the records that existed in the primary DNS will now be replicated out and reflected in Cloudflare. And it's at this point in time that we actually talk about the hidden piece of this of configuration, because this is really what comes into play. At the registrar, the domain registrar, we are actually removing the primary DNS servers as name servers from the domain, and we are replacing them with a set of Cloudflare secondary name servers that are created when you actually build a zone. And this is kind of why it's referred to as hidden, because those primary name servers are not responsible for answering DNS requests any longer. And to the outside world, if you do like an NS lookup, the only thing you're going to get back is Cloudflare secondary name servers. And this also means that because those servers are no longer answering DNS requests from the wider internet, that you can lock down the firewall in front of those DNS servers for ingress traffic to only be coming from Cloudflare IP space. In addition, you can also set up what's called notify IPs on the primary DNS server. And this is a set of IPv4 and IPv6 IPs on the Cloudflare side that when a DNS change is made, it automatically kicks off a zone transfer, even if it's outside of the refresh window, so that we can see that change reflected as soon as you make it on your existing DNS infrastructure. And like with our primary only configuration, if a customer is using DNSSEC today, there are considerations that have to be made prior to go live. In a hidden primary configuration, I generally see customers use what's called our live signing option, which means that you don't have to have DNSSEC configured and enabled at the primary DNS server, and that DS records provided by Cloudflare will actually be the ones that are entered at the registrar. There is a couple more DNS configurations that I'll cover briefly. Primary secondary is really similar to what we just talked about in the hidden primary configuration. But instead of removing the responsibility of the primary DNS servers from answering UDP53 requests from the internet, both Cloudflare secondary name servers and the primary DNS name servers will resolve queries, but the zone information will still be held by the primary servers. And again, it's updated on the Cloudflare side with those AXFR or IXFR transfer records like we talked about. And then the last configuration that I see, but it's again, these last two are nowhere near as common as those first two use cases that I was referring to. Cloudflare can even act as kind of multi-primary, in which case both Cloudflare primary name servers and the existing primary name servers are listed at the registrar, and both answer DNS requests, kind of based on it's really kind of round robin. And so in this configuration, there's no replication method for DNS records. So while it does provide redundancy, meaning if one service goes down, Cloudflare will kind of pick up the slack, or if Cloudflare were to ever go down, the other DNS server would pick up the slack. Uh, the problem is that there's an administrative cost to this, because this means that you kind of have to maintain two separate zone files. So administrators are kind of doing double work unless you're doing things like scripting or using some sort of infrastructure as code. You're kind of responsible for maintaining those zone files in both places. I've included as part of the presentation, I've included some DNS resources that will get sent out, kind of as part of this presentation. But other than that, that kind of concludes the portion of this that's the presentation, and I'll kind of take questions now from anybody that kind of has any.
Hey Derek, that was awesome. We were getting some questions throughout that you kind of answered on the way. One that kind of stands out that I know you can touch on pretty quickly is, do I need to transfer my domain registration to Cloudflare? And the second part of that kind of combined is, does it matter who my web host is actually hosting the website?
Those are great questions. So from the domain registrar perspective, you do not have to use our authoritative DNS. And actually, um, it's kind of reversed on the Cloudflare side. If you want to use us for as a domain registrar, because we do have that feature, you actually have to use us as authoritative. It's a requirement to take advantage of using our domain registration. And to piggyback off of that, uh, you absolutely, it does not matter like kind of where the underlying infrastructure is hosted at from a website perspective. As long as we can publicly route traffic to it, we can support CNAMing things over to other providers. Obviously A records for things that have IP, dedicated IPs on the public internet and things like that. So there's no real requirement as to where things have to be hosted. I know we only have 1 minute left, so I will turn this back over to Anna to kind of wrap up.
Thank you, Derek and Tim. If we didn't get to your question, we will certainly follow up with you offline. I want to thank all of our participants as well as our speakers for being with us today. We hope this webinar has been helpful for you and your organization.